Today, I will briefly present our Assignment 1 project titled Smart Waste and Intelligent Waste Collection and Monitoring System for DBKU. Currently, Dewan Bandaraya Kuching Utara uses a manual waste collection system with fixed schedules and routes. Trucks collect waste regardless of bin fill levels. This causes several problems such as fuel wastage, high operational costs, and even waste collection and increased public complaints when bins overflows. To address this issue, our team proposes Smart Waste, a smart waste management system that uses IoT sensors, real-time data monitoring, and route optimization. Sensors installed in bins measure fill levels and send data to a central dashboard. Using this data, the system generates optimized collection routes, ensuring trucks only collect bins when necessary. The measure of value, or MOV, for this project includes a 25% reduction in fuel and operational costs, 15% faster collection routes, reduced public complaints, and a 10 to 15% reduction in carbon emissions. This project strongly aligns with the Sarawak Sustainability Blueprint of 2030, supporting smart and sustainable governance. We evaluated three alternatives: doing nothing, purchasing existing software, and developing a custom system. After comparing costs and long-term benefits, we recommend a custom smart waste system, starting with a budget of a 200,000 ringgit pilot over 6 months. This approach minimizes risks while allowing DBKU full control and scalability. In conclusion, smart waste provides a cost-effective, sustainable, and a data-driven solution that improve operational efficiency, environmental impact, and public satisfaction.
Hello, I'm Normaisa Bishamsa Fansuri 97640, and for assignment 2, we focus on the planning and scope of the Smart Waste project for DBKU. Our core objective, the MOV, is to achieve a 25% reduction in fuel and labor cost. To manage this, we develop a WBS, basically a work breakdown structure, categorized into four sprints: planning, analysis, design, and implementation. We've allocated a specialized four-man team consisting of a project manager, system analyst, IoT engineer, as well as data analyst to ensure every technical requirement of the Sarawak Sustainability Blueprint is met. The project is structured over 125 working days starting October 2025 and concluding March 2026. As the project manager, Hazik's focus was ensuring that we hit our 6-month MOV window. To do this, we identified a single critical path with zero float. Because the software integration is 100% dependent on the IoT hardware calibration as well as the procurement, any delay would break the system's logic. The critical path is basically the hardware procurement and the system integration, followed by the pilot launch on the real life environment. The flexible tasks that we, the four-man team, can be used and utilized are basically the dashboard as well as the staff training docs. Main key takeaways in this is that the zero float means that any delay in hardware would result in the delay in launching. Thank you. Finally, the project operates on a budget of 200K. This covers the MVP, the minimum viable pilot, focusing on high density areas within the Sarawak where the ROI will be most visible. We've also addressed risk management, specifically focusing on the sensor reliability and the IoT connectivity in urban dead zones. By the end of this 5-month pilot, DBKU will have a data backed blueprint to scale this technology city-wide. Thank you.
My name is Mohammad Khalid Reza. Now that we have reviewed the MOV targets, I want to elaborate on how we navigated the triple constraint after the request for a 10% schedule reduction and 20% budget cut. This left us with a target budget of 158,464 ringgit and a compressed timeline of 112 working days, which equalizes to 5 months. To protect our project value, we didn't just cut costs. We improvised our execution strategy through two core management workarounds. Our first workaround was strategic sourcing and infrastructure optimization. We have saved 9,000 ringgit by pivoting from international vendors to local industrial grade sensor distributors right here in Sarawak. This eliminates shipping risk while maintaining real time accuracy. Furthermore, we have optimized our cloud budget by 2,000 ringgit by choosing a reserved instance subscription for the 6-month pilot rather than an on demand model. By focusing our logistics to 3 high density zones instead of 5, we have saved another 4,000 ringgit while ensuring we had the most rigorous data points to validate our fuel saving MOV. Simultaneously, we had to compress our timeline from 125 days to 112 days. We improvised using parallel task efficiency, specifically a start to start link with a 5-day lag between Sprint 1 and Sprint 2. This allowed the team to develop the dashboard while hardware was still being calibrated, eliminating idle time. To further reduce labor costs by 24,616 ringgit, we automated our administrative closing phase. By using the central dashboard to auto generate our project retrospectives, and MOV evaluations, we cut 20% of the manual labor hours required during the final 15 days of the project. By prioritizing these efficiencies, we ensured the smart waste system remained financially viable and on schedule without sacrificing the 25% fuel saving target. To explain how we physically implemented these changes through our chosen conversion strategy, I'll pass it to Hazik to discuss the following.
And now, moving into the implementation phase, we had to decide the best way to transition DBKU from their manual waste tracking to our new smart waste IoT system. We have officially selected the direct cutover strategy. This means that on a scheduled switch of a weekend, the old manual logging stops completely and the new IoT sensors and dashboard go live immediately. We chose this over a parallel strategy because maintaining two systems would be too expensive and confusing for the truck drivers. We also rejected the phase approach because the route optimization algorithm works best when data is collected from the entire city at once, rather than just one street at a time. To ensure the project is closed professionally, our team developed a comprehensive project closure checklist. This is not just about turning off the lights, it also involves number one, technical handover, which is to ensure that DBKU staff are fully trained on the dashboard. And then we have contract finalization, which is to finalizing payments to sensor vendors. And then lastly, we have the asset release. This means to release our project team members back to their functional departments. This checklist ensures that no loose ends are left and that the client is 100% satisfied with the delivery. Finally, we must measure if we actually delivered the value, of course. We will evaluate our measurable organizational value, which is the MOV, by comparing the new data against the old baselines. Number one, we have financial. So financially, we are looking for that 20% off reduction in fuel costs by checking the new optimized route distances against previous fuel logs. And then two, operationally, we aim for a 15% increase in speed for route completion. By using the real-time sensor data, trucks should no longer be able to visit empty bins, allowing them to finish their rounds much faster than the all-fixed schedule. And then the lastly, which is number three, socially, we will monitor public complaints through the DBKU portal. Our goal is a 15% drop in reports of overflowing bins and directly improving city cleanliness. Thank you very much.